Hi again, this is the fourth video in our ongoing series. And this time I hope to finally get past some of these audio issues I'm having with Kazam. Feel free to leave me a comment or shoot me a note or something if you have any experience troubleshooting Kazam, because I have no earthly idea what is wrong with it. It has gone squirrely on me a couple of times, so maybe this time we'll get through this. But Kazam is just what I'm using to capture my screen sharing over here. So now that I've had practice making this video a couple times, hopefully it'll be a little better. So let's jump right into it. We've gotten to the point where we have a chessboard, and what we need to do now is just sort of take things to the next step. Now, this next piece is really not necessarily anything that exciting as far as user interface or anything like that, but it should give you a feel into how we're progressing with programming in general, and just give you an insight into how to think as a programmer, and to play with some of the tools we're learning, and give us a chance to just exercise some of these skills a little bit. And then we're going to introduce one little new concept at the end that we're going to take to the next level in the next video. So let's see where I am here. I'm in my chess lab branch. If you're coming back in from it having been a while, you can sort of come into this video by seeding into your code in your chess lab, wherever that is. If you check out this get branch function, see where we are. We're at part 3, and we're working towards part 4. So what we can do is get status, and everything that I changed before, we want to just go ahead and check all that back out, which we can do by doing the checkout command. And if we do dot, we should get everything new. Yep, back to where it was. Okay. And we're on branch 3. Okay. So what we want to do is we've got a little bit of a problem. Let's see what our chess game is doing right now. Npm start. The problem that we're having here is that we're kind of not, we're doing something a little wrong here. We're saying this is G3 and it's not. And we're saying this is A1 and it's not. And we're saying that's H8, that's not. The chess notation is going to be different than what we decoded, as far as we've got these rows and each row has a column in it. Some people might be thinking that it makes sense to flip all of this around a certain way and then display it in such a way that there's no shenanigans involved in rows and columns. Right here is where we're going to be displaying each cell, and so we're looping through each row, and then for each row we're going to loop through all of the columns. I think it helps to be able to see this in sort of the same representation that we're going to see it on this board. And then the only question is the representation of A1 through A8 and H1 through H8. So obviously some things are flipped around here. And whenever you see we're repeating ourselves here, we're decoding this in more than one spot, and then we've got an encode step here. We're going to be having to do that one way or the other. So let's start to pull that out. And what we really probably want to do is have a couple of functions. Let's start with one that does, let's grab this first. We can just copy it. And we'll write a new function called getID. And we're going to need a row and a column passed into our function. So we can just paste this. And I probably don't need to store this variable. We could probably just return this. So let's go ahead and I think there's only one spot we're really calling this, which is down here. We'll do a call to this dot get ID. We can do props dot row num, props dot call num. Okay. So right now we want this to just do the same thing it is doing. It's mad about something. What is this? Props is not defined. Wow. That's weird. Props is not defined. That doesn't make a ton of sense. Oh, I see. It's props up here is not defined. Okay. I copy and pasted that. Row. Yeah, look, it says line 24. Right here, line 24. So we need a row there and column here. Alright, cool. Alright, things are back to normal. A1, BP, D2, okay. D2, G2, okay. So that's cool. We were able to take that, and now we can manipulate it here, and anywhere else that we need to get an encoded ID from, we just call this function. So the next thing to do is to do that for these, so that we don't have to, if we're monkeying with one of these, we want it to change both of them. So let's do a function called decode position. And in this case, we're undoing the ID, right? So we can do the same thing. Let's see. Copy. Alright, now with a little bit of JavaScript magic, we should be able to just return row call, and that'll return them as like an array with two things in it. There we go. And instead of selected, we want to do ID. Right? Cool. See if we got any errors. Nope. Looks good. So now instead of sort of doing this with two calls here, we can just call this function decode position. So we'll do let, and this is some more JavaScript magic. You can automatically sort of unpack an array by saying row 1 call 1 equals this dot decode, and then the ID that we're passing it, this one's coming from this dot state dot selected, right? Because we stored that here in a previous call to our select function. Remember, our select function is getting called whenever you click. So if you don't have anything selected, you're going to save that value there, and then the next time you click to move the piece, we're going to be in here, and we're going to decode that one first. So now we can delete this one for 1 and 2. Okay, so we should be able to do the exact same thing, a little cut paste engineering here. But this time we're going to do ID, and we'll do row 2 call to. Right? Cool. So now we've got these two complementary functions, and we're having a little error. Oh, that makes sense. We can't define stuff twice, so we have to delete this one. Makes sense. Less code is better. So we got rid of that old code. And now we don't have to worry about how we're decoding a position or how we're getting an ID for a row column. We're going to be able to manipulate both of these functions in order to be able to display. Let me save this. Is that good now? We're good. So let's make sure everything works. We're at A1, H1, H8, A8. Okay. So things are kind of flipped around here. Let's think about how we might approach this from a test-driven development point of view. So let's see. We've got. I'm cheating a little bit. I'm actually looking at the next part to this code. The way that you might want to approach this is to write a test that sort of instead of testing any of this, we want to test whether we can do app.getID with 0, 0. We're going to get an ID out of that. And right now it's going to be what? 0, 0 is A1. So we can check that by doing expect ID dot. Now we've only done 2B in the document, right? But I happen to know if you look up testing or whatever, you can do some other stuff here. We can do 2 equal. We could say A1. And so now let's go ahead and quit out of this. Control C. Remember, quit's a program. Well, let's do Npm Test instead. Okay, we've got a problem here. Now, the reason, well, first of all, you'll see that it says renders learn React link. So it's going to tell you that the problem was whatever you wrote here. So we want to write something like test correct chess square code. All right. Now the problem we're running into is that I'm treating this like a singleton. And what that means is this is a class, not an instance of a class. You can't just call functions on the class itself, right? So under the hood, React, when it renders something, you're telling it what class to use. It's actually going to call the constructor for that for you when it's setting it up. It's going to make an object for you that then can be called by various things. So what we need to do is mimic that, and it works like you'd expect if you've ever done any object-oriented programming before. You can just say, well, I guess you wouldn't say app in this case. We could just say const equals new app. It works just like you'd think. And we actually have to use the object instead of app. Okay. There we go. But this is wrong now, so we want to change this first. We'll see that it's broken. And the top left square should be A8, I believe, right? And then additionally, A8 should... we should be able to do object.decode position of ID, and we'll get an XY. You gotta type it all in. Okay. So we're gonna get a row column out of this, and hopefully expect X dot to equal 0, and we'll expect Y to equal 0. So if we're going to be thorough right now, we'd also run the other corners. We could do one corner. We could do all four corners. If you're feeling crazy, you could check the entire board. I don't really think that that's really worthwhile. The corners are going to really test whether this makes any sense, and then we can play with the game to test whether it's doing what we expect a little bit. Designing tests is one of those things where you're trying to test as many edge cases as possible. You're not necessarily trying to test all the possibilities. You're just trying to make it so that if there's a change to this code, that has to be reflected in the way it's tested. So right now we should get a bunch of broken tests. Yep, we're not getting A8, and it tells you this is what was wrong and this is what we expected, so it doesn't proceed. So we can just leave that going, and then once our code is fixed here, we'll see green check marks over here. So we can just play with this code kind of until we get it right. And that's one of the things about test-driven development is sometimes you'll work on teams where they'll want, they'll say, hey, you write the test, right? And then I'll write the code and make your test pass. And then I'll write another test that doesn't work. And then you switch places back and forth. It's called ping-ponging, actually. And that's also a form of pair programming. That kind of programming can be really popular at really big organizations. It also gives then you've got two people looking at the code, and you've got people sort of making natural agreements about how things will work and checking each other. It's a kind of a good way to work. And sometimes I work like that just by myself, just back and forth, make a test, try and think about how I can prove that it works. You'd be surprised how often you write some code and write a test for it, and the code looks like it works when you're playing around, but as soon as you write a test that really gets at the corners or something, that's when you realize there's a bug. So let's think about this. Instead of we've got a kind of a tricky problem now. We kind of have to flip things around. So what we want to do first is flip around the fact that we're doing a column here, because we're counting the columns count down instead of across. So we want to flip that around and use the column as the first thing that becomes the letter. So 65 is the ASCII code for the letter A. So if we have A, it's going to be 0, and a 1 is going to be 66, which is B, etc., etc. Luckily, ASCII is in order of the alphabet. And so instead of column over here, we're going to have row. And that means we need to flip these two and do column for the first letter and then row on this one. So now, at the very least, they're going to match. A1, A. So there's still, if we were, the test here, if we had, let me do another test. Let's say we did 7, 0. And what is that? 7, 0 would be 7, 0 would be this one, right? H1. But really it'd be A1. Right? So XY 7, 0, A1. Let's see. Interesting. Okay, so yeah, A1. We got A8. So we've flipped it. We've successfully flipped it around. We're not getting H1 anymore. We're getting A1, which this stays up now. It's already loaded and everything. If we refresh, it'll have an error or whatever. But this is still our old code, so to speak. And before, when we were down here, we were at H1, and that's because of the way we were counting rows and then columns. So now that we have the ability to decode and encode a row and column, and we've flipped which one is which, we're getting the reverse answer. So now this one, A8, if we did 0, 7, then we ought to get H1 up there. I think. This is kind of confusing, to be honest. So that's one of the reasons it's important to do test-driven development when you have this kind of code. It kind of makes sense. So let's see. What we have to do now is we have to sort of count down on these numbers instead of counting up the way we're counting now. And they're flipped now, so let's look at what that looks like actually. Let's Control C and we'll npm start. We should get a new window. Okay. Let's see how this works. So now this one's A1 and this one's A8. So now this one's B1 and this one's B8. Okay. So we've got it flipped around correctly. The problem is we're counting up because each one of these rows is getting rendered and then counted by this map function. So this map function gives you both the thing you're going through and then it also gives you like an index. So it goes 0, 1, 2, 3, 4, whatever. 0, 1, and we're adding it to 49, right? Up here. So we're adding that row to 49 and we're going, each row we're going in and saying, okay, 1, 2, 3, 4, 5, 6, 7, 8. So now we need to flip that around. The way to do that is that we want to start by subtracting by the maximum index number. So the maximum index number is going to be 7. So if we have a 7, we're going to be 0, right? So we want to flip it around so that we count down instead of up when we're getting an ID. So the way to do that is to subtract that off of the row. And to do that, we just need to parenthesize it. It's like an order of operations math thing. So we want to do 49 and then 7 minus row. Okay. And then, yeah, actually, okay, that works. But the problem is we haven't done this thing yet. So I bet this will do weird things if we try to move it. Yeah, look what it did. So I clicked here, trying to move this piece here, and it ended up decoding and moving this piece here. So it did the opposite move. I bet we could do that here too. This one, here. So if we select this white pawn down here and move him up, the black pawn moves down. Okay. So now that we've got that, we've got to fix that. Let's go ahead and kill this with Control C. And we'll use our up arrow key a couple of times. We can go back to Npm Test and hit enter. And now it's passing because we changed our test. So we actually want to say 0, 0 is A8, right? Now this should fail. Yeah, okay. And the problem is we decoded badly. So now we need to fix this part. So we got to do the opposite thing. And instead of, so the problem is now we're turning this inside out, okay? So the math needs to happen on the outside of this. If you want to think of this in reverse, there's a little bit of algebra you can do here to sort of satisfy yourself with this. But at this point, we need to do the same thing. We need to do 7 minus, right? So let's say we have an 8 there. We're gonna end up with a 0 if we're at 49, because we're doing minus 49. So we have an 8, we do minus 49, we get to 0. We need to do 7 minus in order to decode that right. Alright, we passed. Cool. We could write a couple more tests here. We could do, we could take a couple of corners of the board, sort of satisfy ourselves that we're doing the right thing. Let's do 7, 7. That's the other corner. So that should be H1. And then we should get 7, 7 back out of it. And we got to get rid of this let, because it'll be mad. Alright. Hey, cool. And you know, we can do, you could break this into more than one test if you want. You know, you could bottom corner, bottom right corner, you know, and then you could have your lets and everything in there again. Sometimes it's easier to copy pasta a whole bunch of stuff by sort of having a bunch of tests that are the same. And sometimes there's a little psychology effect here too, you know, with making it so that you see a bunch of tests passing. There we go. Now we got 3 tests that pass. That's cool. So now we've got our board. So I bet if we do Control C out of this and do npm start, hopefully our board is back to working correctly. Instead of working backwards. Let's see. Hey, look at that. And we're still allowed to move everywhere. We haven't put any constraints on anything other than you can't take the same color you're on. So, but that's working correctly. And it's saying HG1, F2, E2, E2 to E3, or E2 to E4. Those are the popular openings. And so is G2 to E3, G3, or whatever. So that's working good. And we can feel good about it. We can write all kinds of tests for this that exercise each part of the board if we want. But now the nice thing is we can kind of forget about that piece of code. We can, we've got that safely tucked away there. So the next piece that we want to, I think, play with a little bit is making these kind of look a little bit. They look like, this looks bad. Black rook, white pawn. I mean, it'd be nice to get some symbology here. One of the things that you'll find is that it's actually really easy just to Google stuff. In this case, if you Google React icons, look at that. You get React icons. You'll notice I've visited this page, right? I don't know what React icons Netify is, to be honest, but NPM is where we want to be. And the nice thing you'll find is that it really is this easy. You can start using certain icons, and their examples work. There's a lot of cool stuff on this page. If you check out a page like this, or you don't have to use this example. You could or make your own, but you can see that this is a really popular package. Hundreds of thousands of downloads every week on a steady basis. It's got a good license. This license means you can use it for whatever you want. It's kind of big, 23 megabytes. Can you imagine? Let's play with this a little bit. Let me show you how this works, and then we're gonna in the next video dig a little deeper into how this is gonna get set up to give us a more interesting looking board. But see how this works. We're gonna go back to our terminal window and hit Control C. And just like they asked us to do, you can paste it right in there with Control Shift V, or with right clicking and hitting paste. And as promised, when you run this command, it's gonna do its thing. And what's cool about this is it's gonna be ready to go right out of the box. What it's got to do is all the stuff it needs for you to be able to do this exact example. All you have to do is import an icon, and then you can use it. And sure enough, here it is. It ran. It didn't find any vulnerabilities. It apparently audited hundreds of thousands of packages. And what you'll find is it put this into node modules. So if we ls node modules React, where is this? Icons, there it is. You can look at that if you want. Over to your code, copy this right to the npm page. Of code in the world, language. More thing, let's use it. So instead, use that. And then we got to go back. All the code it needs to use that library we're importing, and it will have saved the exact library that we need in those package JSON files. Let's see how we're doing. Firefox is ready, apparently. Is this going to work? Oh, there we go. We got a beer on every piece. So next week we'll talk about what the right thing to do is with that, but that at least gets us, which is going to be of value out of this npm. There's different types of icons are pretty valuable. It encapsulates here, let's see. We can go to the see exactly how they you can use material from here. And then what chances are good how does the code look like, license look like? I mean, it does happen that occasionally you'll find something licensed that was something that you don't like. Usually if it's on npm, it's got a permissive license, but you never know what you're going to come across, and they always include these. It's just a ton of resources for you to go through and add stuff. That's it. Part 5, we're going to talk more about how we're going to actually make this board look a little more interesting. So stay tuned.